Yes. So, shift gears slightly. Only slightly, because what Ariel, I've been giving credits for 3 weeks now, I think. It's okay, that was a good one, it's a good one. I want to switch back to the topic we were speaking of on Wednesday, which was the Monty Hall problem, and the relationship with the Monty Hall problem. Remember the Monty Hall problem we spoke of in class?
Yeah.
Go ahead, Benji.
My question is, we simulated Monty Hall
Yes.
using Excel.
Yes, we did.
That you put a formula for
I did.
step 1, step 2. What was that? Like, will we have to?
No, you don't. No, you don't have to know it at all. What I did was I essentially had to create a random switch between two doors. Right. It was an if-then statement. And what it ended up being, the reason it was so long was because it ended up being quadratic, because there were two doors, and each door was a multiplication of probability. And I had to solve that for x given y. No, you don't have to know that at all. That was just me trying to be as random as making Excel be as random as possible. No formula, no formula. That was just a simulation.
All right.
If you want that, eventually, I've been threatening to do this for 9 weeks now. I'm going to have all my Excel sheets in one place so you guys can get to them. You may have to come back after the class is over to get them, unfortunately, because I'm not going to get it done until Christmas break. So, busy making rock videos. So, I will get them, because I want you guys to have them. I think Excel is an invaluable tool. We're going to use about 5 or 6 of them today and Wednesday to really explain what the hell's going on. So, thank you for that question, Benji. So, the Monty Hall question. 3 doors. You pick a door. What did we learn? Well, you pick a door, Monty goes stand next to it, and then he opens another door. What did we learn on Wednesday?
The odds like merge.
Yes. So is it better to stick with your door or switch to the other door?
Switch.
On average, you win twice as much, don't you? Or twice as often, not twice as much, twice as often you win, yes? Remember what it was? It was 1/3, 2/3? And I love the word merge over here. That was awesome, Andrew. Yes, because the chance of you picking the door correctly on the first shot is what?
33.
For 33%, 1 in 3. 1 in 3. You're only going to hit it 1/3 of the time. Which means when he opens a door, he's doing you a favor. Most of the time. Because most of the time, you've already picked the wrong door. You've picked the wrong door 2/3 of the time, yes? You've picked the wrong door 2/3 of the time. So if you've picked the wrong door 2/3 of the time, you should clearly switch to the other door that he's not showing you. Because 2/3 of the time, that's where the price is going to be. You only got it 1/3 of the time. I'm sorry, I drank a lot of chlorine today, so I'm squeaky. You picked the right door 1/3 of the time, which means you picked the wrong door 2/3 of the time. Fair enough? Does this mean you're always going to win if you switch? Of course not. Doesn't make any sense at all. Doesn't make any sense at all. But it means 2/3 of the time you'll win on average over time. This gets tricky because you don't play the game over and over and over and over again. You play it once. But that's the idea. Exactly, exactly. But if you want to maximize the chance of what's going to happen to you being correct, you switch the door. And this happened, believe it or not, in the game Deal or No Deal. Not that long, but maybe a year or so ago. It was down to 2 cases. Now, if you've never seen Deal or No Deal before, Deal or No Deal, there's 26 doors. Let's call them doors. They're actually suitcases held by scantily clad women, which is ridiculous. But there's 26 doors. But the difference with Deal or No Deal is each door has something behind it monetarily. It's a penny, 5 cents, 10 cents, like $1, $5, $10, up to $1 million. And sometimes they futz with that a little bit. They make like a 700 or a $3 million or $5 million case occasionally, but usually it goes up to $1 million. You pick one case, and Howie Mandel, if he's still hosting, I think he is, puts it down next to you. And then one by one, you start pulling cases away. So essentially opening doors like Monty does.
The Monty's doors aren't weighted. They're either...
No, either on or off. Now, we discussed that sometimes Monty does have other stuff behind them, but this one always has other stuff behind it. But the difference, and then why this game is so genius is, that Deal or No Deal is, they'll stop every once in a while, and this banker that's sitting up in the office with a telephone calls down and says, I'll give you this much money for the case that's in front of you. And he offers you some, and I'm still working on figuring out, that's what I would have done if we had one more week. We would analyze more data on that, because you can play that game online. We did it last term with my 105 class, and try to figure out how much the banker offers you based on what suitcases you open. We were almost there, and then the term ended. But, so eventually, if you keep playing the game all the way through to the end, you're down to 2 cases, the one you've picked and one that's left. And there was this one game where there were 2 cases left, and the 2 amounts that hadn't been opened yet were $750,000 and $1 million. which means all the other cases except those two were open. At this point, you just celebrate, because no matter what happens, you're going to walk with a chunk of change. But the person said, I want to switch. I want to switch. And they did, and the case that was not theirs was the $1 million case. Because the likelihood of them having the $1 million case in the beginning was only 1 in 26. There's a much better chance they don't have the $1 million case, yeah? There's only a 4% chance of each case being picked. When you go and grab a case, there's only roughly a 4% chance that you've gotten the $1 million. There's also a 4% chance you have a penny. There's also a 4% chance you got the $750,000. There's also a 4% chance $500,000, and so forth and so on. But when you get down to the end, there's only still a 4% chance that whatever you have in front of you is the $1 million. That doesn't change. What changes is what's popping up behind on the screen. And this is, I'd love to play this game. We might do this next week. We'll see. We'll take a vote on Wednesday. Because it's an interesting game mathematically to see what's going on as far as what's happening. But anyway, all of those games are based on one big idea, and the idea is probability. All of those games are based on probability. What is the key word or key section of that word? Break it down by etymology. What's the key part of this word? Probable. Good. Probable. Is something probable or is it improbable? So there's all kinds of derivations of this. Is something probable or is something improbable? Now what I wanted to work on today is how to measure two things. I want to measure probabilities, and I want you to understand what those probabilities are. I think a lot of us have some probabilities, like kind of in our minds already. We know already kind of intuitively what probabilities are, but I'm not sure we could explain them to somebody if we needed to. So we're going to start with that. So I'm going to start with a question. Over here. Actually, we'll start with an experiment. Let's do an experiment. Experiment. Flip a coin. And we're going to assume it's a fair coin. A penny or a quarter or a nickel or anything.
IRL, or are we loading up our here?
I can't find my pennies. We may have to use, if you have coins to use, you can use your coins yourself. That's totally fine. If you don't have a coin, we'll use the TIs momentarily. Let me ask the question first, Benji, if it's okay. Because I got a feeling most of you are going to have an answer for this right now. And then I want to ask you further. What is the chance? What's the chance or probability you get heads? 1 and 2. Vote for 1 and 2? Good. I think I heard somebody say 50-50.
I just meant 50.
50%. Oh, that's what I heard, Kirsten. Thank you. 50%, which is 1 and 2. Yes. Thank you. I love that. What does it mean? You have a half chance. Good. What does that mean? And I'm not just asking Kirsten. I'm asking everybody here.
It's a chance for both.
It's even odds. I like that. It's even chance. So if it's 50% for heads, the other outcomes, in this case only one, have to also be good. Kirsten, you bring up a good point. I'm going to put some sub-notes over here on the side of this, because Kirsten, you've actually gotten right ahead of us. Thank you for that. So there are a couple things you have to know about probabilities, and this will make more sense later on when we get a little more technical. All probabilities, whenever you measure a probability, the smallest it can be is 0. Can't be any smaller. You can't have a negative probability. We'll see why that makes sense momentarily. And the absolute largest it can be is what? 1 or 100%. And thank you for saying 1 and thank you for saying 100. This is written as a fraction. You can also do it as percentages. That's what Kirsten said, 0%.
If you just wrote flip a coin, what's the probability that you get banana?
That you get?
Banana.
Good! Flip a coin, a normal coin now, not a banana apple coin. But flip a normal coin, what's the chance you get a banana? That's going to be 0. Flip a coin, what's the chance it lands on either heads or tails? There's your 100%. But usually, and those are called like certain probabilities. We know they're going to happen. But there's an old phrase. There's only 2 things in life that are certain. Death and taxes. So there's, I said, maybe you've never heard that before. The only two things in life that are certain, death and taxes. That and Sean's hyperactivity, we'll put a third one on that too. But the point is that most probabilities, that's 0.9999. Most probabilities live between these numbers, and what's fun about them is calculating them. That's what we're going to get into today and also on Wednesday. So thank you, Kirsten, for that. Fantastic. I'm not letting you off as a class that easy. Kirsten said 1/2, or Benji said 1/2. Kirsten said 50%. What does it mean? You might need this now. You might need, if you don't have a coin, you're going to want your TIs. What does it mean? 1/2. We got the even odds thing. I like that. That was very nice, actually. The even odds, the equally likely odds. No? Okay. Let's see if we can answer with an experiment. Here's what we're going to do next. What I want you all to do, I'm going to swing the camera over here so you can see what I'm doing. If you have a coin, fantastic. Use that. If you don't, we're going to use our TIs to simulate one. If you also don't have a TI or a coin, I'm sure your cell phone can generate this somehow. We can take a look at it. We're going to use the random integer command on your TI. So we've done this before. We'll do it again now. So what I want us to do is fire these things up. There, focus. Drop it. Okay, go to your math menu. MATH. Then go over to left one to PRB.
Probability.
Probability. That's exactly what PRB is. Probability. Yep, we like this a lot. We're not going to get too far into it in this class, except for maybe rand. Go down to rand int, number 5. Rand int. Now, let's pick between 1 and 2. So type 1, then a comma, then a 2. And then close off the parentheses. I'm going to assume, we did that random seeding before with our birthdays, right? Because we've done this before already. We've already seeded these things for randomness. I think so. Okay. Everybody just press enter right now. Okay, I got a 1. Who got 1s with me? Who got 2s?
That's one.
We haven't decided yet. Let's Tori, that's fine. We're going to make heads 1 and tails. Did that close itself or somebody close it on? Close itself. We'll open it again. So we're going to run this experiment momentarily. Here's what I want you guys to do. Now, one thing you can do to speed this process up, press second enter. Oops, second enter. And bring your cursor back on top of the parentheses. Hit a comma. And then type, let's see, there's a whole bunch of this today, yeah? Hit 10. 1 comma 2 comma 10, and then close parentheses off. What do you think it's going to do now? It's going to do it 10 times. So now when you press enter, you'll see a string of 1s and 2s, 1s, 2s. So I got 1, 2, 2, 2, 1, 2, 1, 1, 1, 2, 2. Does that make sense?
So did we decide what it's going to be? Because some of us are flipping coins.
Yes! We'll get to that in a second. So you press it again, you get 10 more random numbers. Press it again, you get 10 more. You just flip 30 coins. Does that make sense? So here's what I want us to do. I want you each to flip 10 times, and what you might want to do is just kind of press it until you get tired of pressing, and then just stop, and then look at that last trial and count that as yours. Let's make a 1 is heads. Let's make a 2 tails. If you're flipping coins, just flip coins and keep track. But here's what I want you to do at the end. We're going to fill that board with your results. So I want you guys to walk up once you've done your 10 trials, and then write H's and T's for what you got on that sideboard over there. I'll start with mine first, and then we'll collect the data all together. That make sense? Is that fair?